In this section, we're still going to talk about surface area, but we're going to talk about composite figures with surface area. Now, we've only done two different shapes, so a prism and a cylinder, so those are the only two combinations of shapes we're going to use for this one specific section. But realize later, once we add in a cone and a pyramid, that you could start seeing some composite figures with those figures as well. Now remember, composite volume, when we had done composite volume, it didn't matter if the shapes were touching or not, that we could just add the individual or subtract the volumes to each other if there was a hole inside of it, or if it was just laying on top like this one, we could just add the two together. But if it's surface area, you have to think of where we paint on the outside, and not all the areas we can see. So we need to either add or subtract some individual surface areas together, and if there is an area that is missing or that's touching, you'd have to subtract out that area where they are touching. And it does matter if the solids are touching, that it makes a big difference on the surface area. So on this first question, number 1, we can see that we have a prism on the bottom and a cylinder on the top. And the part that is not included in the surface area is that circle area right there in the center. So not only will that affect the surface area for the cylinder, but it's also going to affect the surface area of the prism because we cannot see that area. That means that our prism surface area, we need to take the total surface area of the prism. But for the prism section of it, we need to subtract out the area of that circle, so pi r squared, because we don't see that area with the prism. Then for the cylinder portion, we need just the lateral surface areas, that would be around the outside edges, and that would be my 2 pi RH. So I need around the edges of it, and I just need one of the bases, so not two bases, but just one of my pi r squareds, because that's just the top section of my cylinder that we can see. So if you notice with our formulas, these parts are going to cancel out, so it's going to end up being just my total surface area of my prism, because think of that circle is then replacing this top circle, because that's going to be the same size, and then we're adding on the lateral surface area of our cylinder. So now we can fill in all of the pieces that we have. For the perimeter of my prism, I take my 9 plus 9 plus 4 plus 4, and I get 26. For the height of my prism then would be the 5. So that gives us a 26 times 5 here, plus 2 times the area of my base. So 9 times 4 would be a 36. This gives me 130 and then 72. So if we add those together, the size of my prism just alone is 202, and that would be centimeters squared. Now we need to move over to the cylinder. So my radius for my cylinder is my 2. The height of just the cylinder itself is 3. So that'd be 2 times 3 is 6, times 2 is 12, so we'd have 12 pi that we are adding onto this. Now, if I wanted to leave my answer in exact form, that would be it. If we want to round our answer, it would be 239, because it's 239.6991118. So we're going to stop it right there, so we would just leave it as 699, and this would be centimeters squared, and this would be our non-exact answer. Now in number 2, it makes it a little bit more challenging because we have a hole in the inside. So I first want you to name the two figures that are shown in our picture. You should have chosen that it is a cylinder and it is a prism. And what we need to do then for the total surface area is we need to use the total prism, but if you notice for the prism part of it, we're going to have these little holes for the circles that we will not want to include in there. So we need to subtract out 2 of the circles. So to show you what we have so far, we have our total prism surface area. We have to subtract out the area of the 2 circles on there, but we're going to have this hole in the inside where we could paint the inside edges. So notice that's the lateral surface area of that cylinder, so we need to add on the lateral surface area of our cylinder. Now that we have our formula all set up, now we can just go through and start filling everything out. So our perimeter of our prism, let's lift that up to over here to the side. So we're going to have 24 plus 24 plus 16 plus 16. When we add these together, we get 80, so exactly 80. Now the height of our prism is going to be our 20. So we can go ahead and fill these first parts in. We have our perimeter times our height, and then plus 2 times the area of our base of our prism would be our 16 times 24. and this gives us 384. So then, once we simplify all this part individually, we get 2,368. So that's just for the prism portion. So now for our two circle section, we have 2 times our radius of that circle is 4 squared, so that's 16 times 2 is 32 pi. So we need to subtract off 32 pi. Then for the lateral surface area of our cone, or our cylinder, sorry, we have 2 times pi. Our radius is still the 4. The height of our cylinder then is the 20. So if we multiply all those together, we get 160 pi. So we're going to add on 160 pi onto everything else. Now something you could do to simplify this a little bit further, if I add these or combine my like terms together first, I get 128 pi, and that would be a positive. So then I can combine that with my 2368. Now remember, if I want the exact answer, this would be the exact answer. So sometimes it's going to ask you in terms of pi, and that's what we would write. Otherwise, if we add those together, we get 2,770.12386. So if we round it to the thousandths, that would be 124. And this would still be feet and squared. And now if we wanted the exact, you would also have to keep your feet squared in there as well.